Hello, this is Professor White. Today we'll talk about word problems that involve rational equations. Certain types of problems involve rational equations. So, to be ready for this, I'll go over those words, keywords that you need to know to do these problems. The first set of words is something that implies equals. So, these are the words, kind of review them. Uses was, were, and those kind of things. That when you see that, kind of like in math, that means an equal. Addition words are these, more than, added to, increased by, those kind of things. And make sure when you see that, it flags an addition for you. Subtraction words, these are flagged by, less than, decreased by, those kind of things. Make sure that when you see them, they flag the subtraction for you. Multiplication words, some of them are kind of more obscure, product, double, triple times, those kind of things. When you see those, make sure that there's a multiplication involved. Division terms, sometimes they are a little bit more obscure. Shared equally, they are kind of like not spelled out. Divide by, quotient, sharing, anything that has, there's a D here, equally distributed. Sharing over something, those are all division terms. So once that you have that, also the exponents, 2 squared, 2 cubed, those are 2, 2, 2, 2, 2. Okay, so make sure that you understand those. All right, here it is. A typical number problem. You have to read it very carefully and put down the key things, okay? Here we go, is a number. One number is 4 times another number, okay? So, like somebody says what or a number, those kind of things, just say X. So that number that I just don't know, first number. Okay, the other number is 4 times the first number. That's the second number. Does it make sense? All right. Now, the next thing it says, the sum of their reciprocals. Reciprocals, that means you flip them over. So, reciprocal of X is 1 over X. Sum of, remember your keywords, that means you're adding them. Reciprocal of 4X is 1 over 4X. It says is, that means equals, 5 over 2. All of a sudden, I have a rational equation. Okay, well, how do you solve a rational equation? We did this before. So your LCD is 4x. Remember what you used to do. You just go and you put your brackets on both sides and FOIL. Now, what do you get when you do that? You're going to FOIL the first one. What is 4x times 1 over x? X's will go. That it will give you 4. Does it make sense? Let's do the next one. What is 4x times 1 over 4x? That's going to give me 1. And what do I have on the right-hand side? 5 over 2 times 4x. Guess what? These two will go. You're going to end up with 2. 2 times 5, that's 10. Oh, 4 plus 1, that's 5. And let's divide both sides by 10. 5 over 10, that happens to be 1 over 2. Okay, so the first number is 1 over 2. Okay, what is the second number? It is 4 times that. 4 times 1 over 2. And guess what? That turns out to be 2. So the first number is 1 over 2, and second number is 2. It says sum of their reciprocals is 5 halves. Is that the case? Reciprocal of that, 2. Reciprocal of that, 1 half. 2 and 1 half, which happens to be 5 halves. Oh, it looks like we did it right. Always have that check at the very end. Another type of problem you're going to have, rational expressions, is a distance problem. And these are very typical problems So make sure that you understand how it works. I always make a table, and most books show a table to do these problems. There are a couple of things you do. These are usually like stream problems. You are going against the stream, with the stream, those kind of things. Downstream means, here's your water. It has a current in it, and you're in a boat, and you're going with the current, okay, together. So what somebody stationary sees is like, it sees a faster person because the current carries you and you carry yourself, then your rate is going to be additive. When you say upstream means, here's your current, here's your boat. You're just going against the current. To be able to even move, your speed has to be bigger than the current. Otherwise, you're going to just stay in place and do nothing, okay? So let's talk about that. This says, Cindy went canoeing in the river with a current of 2 miles per hour. It took her the same amount of time to travel 10 miles downstream as 2 miles upstream. So do I know the time? I don't know the time, but I know that they are the same. Do I know the distances? I took her the time to travel 10 miles downstream. So I know this one is in miles. So I went 10 miles downstream and 2 miles upstream. So I put down the distance. Now remember how this works, the distance problems. Rate is distance over time. That is something that you know. Or time is distance over rate. These two things, okay? Now the second column is going to have the rate. Remember, do I know my rate? I do not know my rate. I'm just canoeing. Okay, well, but I know the rate of the river. When I go downstream, so my rate, I don't know. My rate is, on still water, is R. So on the downstream, the current is going to help me. My rate plus the current's rate. Upstream, the current is going to work against me. Okay, so once I figure out distance and rate, the time column is going to be this formula, distance over rate. What do I have as distance over rate? 10 over R plus 2. And distance over rate, 2 over R minus 2. Now the next step is to put all this together. So let me do it in such a way that you can actually see the table. And then we can do the problem. Here we go. What does that mean? That means determine the canoe speed in still water. So that is my R. And it says that it took me the same amount of time to go downstream and upstream. That means these two times are equal. So my equation is going to be 10 over R plus 2 equals 2 over R minus 2. And guess what? Excuse me. I have now a rational equation. What is my LCD? My LCD is R plus 2, R minus 2. What was I used to do? You just simply put your brackets and multiply by my RCD, LCD, R plus 2, R minus 2, R plus 2, R minus 2. Okay, now let's fold this up. When I do that, these R plus 2's will go. I'll have a 10, R minus 2 on the left. And the right, these R minus 2's will go, 2, and R plus 2 will stay over. Now FOIL, 10R minus 20 equals 2R plus 4. Now I just solve for it. Subtract 2R. That will give me 8R minus 20 equals 4. Add 20. Let's go here. 8R equals 24. R equals 24 over 8, which is 3. 3 what? 3 miles per hour. And that is the rate of my canoe. That's how fast I canoe on that river with a current. There may be problems that may ask you something different. You may say, it took the same amount of time, so that means I set them equal. But there are, in some instances, they may not be the same, okay? So you have to read those kind of key things so that you know what they're asking. Another type of problem that involves rational equations is the work problems, and this is very, very typical. The work problems, you usually have 2 people working, and then they are doing the job alone at certain speed, and then when they're together, they are getting it done a little faster. So kind of understand how to fill out table. Here it is. Linda and John own a cleaning service, so there's nothing in there. When Linda cleans a house, she does it in 7 hours alone. When Linda and Joe do it together, Joe and John, okay, sorry. It's John. Do it together, they do it in 4 hours. How long will it take John to do it alone? Okay? So, this is how we set it up. Rate, time, part of the task you get done. Okay, the task is 1 house. Cleaning 1 house. Linda. The rate is 1 house in 7 hours. So 1 house per hour. So it's 1/7. The rate is work per time. Does it make sense? And she does it in 7 hours. Okay? Now, but they are working 4 hours together. Now let's put down the John. John does 1 house cleaning, but I don't know how long it takes him to get it done. So the X is when he does it by himself. So that's work per time, 1/X. 1 work in X hours. I don't know how he does it. But when they work together, they are working 4 hours, right? So when they're working together, if Linda is working 4 hours and then she does 1/7 of the work, the part of the task is going to be the rate times time, which is 4 times 1/7, which is 4/7. In terms of John, his rate is 1/X, and he also works 4 hours because they are doing it together. 4 times 1/X is 4/X. So this is the part of the task that Linda does when she works together with him, and this is part of the task that John does when he works with her. So let's put these 2 together. So what does that mean? The task itself has to be 1 task, right? Cleaning the house. Okay, I'll just go to the next one. So Linda's portion plus John's portion has to equal 1 task. Do you see it? 4/7 plus 4/X equals 1 task. And now this just became a rational equation. So what do? I go and I find the LCD. That happens to be 7X. And go put your brackets. 7X. Foil it out. Look what you get. 7X times 4/7. 7s will go. You're going to end up with 4 times X for that one. Now, X's will go. 4 times 7, that's 28. On the right, 7X times 1, that's 7X. Let's just solve this equation. You have 28 equals 7 minus 4, 3X. And let's divide everything by 3. X equals 28/3. Which is the same as 9 1/3. Well, 9 1/3 what? That's hours. So John cleans the house alone in 9 1/3 hours. Okay? So that is the answer. He's a little bit slower than Linda, and when they work together, they get it done in 4 hours.